All right, so here we're going to be looking at 1a. Use the definition of a derivative with limits and difference quotients to prove that the derivative of 1 over x squared equals negative 2 over x cubed. No other methods will be given credit. All right, so first what we need to know is the definition of the derivative. What is the definition of the derivative? Well, that is the limit as h approaches 0 of f of x plus h minus f of x all over h. This is your definition of derivative, right? So if f of x equals 1 over x squared, then f of x plus h will equal 1 over x plus h squared, because you just plug this into that, right? So now that you have everything, plug it into the equation, you're going to get limit as h approaches 0 of 1 over x plus h squared minus 1 over x squared all over h, right? Now, what we're going to want to do is you're going to want to combine these two and cross multiply to allow them to have the same denominator. So this is going to be times x plus h, x plus h squared over x plus h squared. And this is going to be x squared times x squared. So that's going to be the limit as h approaches 0, x squared over x squared times x plus h squared minus x plus h squared over x squared times x plus h squared. And this is again going to be all over h, right? Now, we can combine this to be x squared minus x plus h squared all over x squared times x plus h squared. And this, again, is going to be all over h. Alright, from this step forward, we're going to want to expand out x plus h squared and cancel out all the like terms. So, expanding, let's not forget the limit here. Expanding this out, it's going to be x squared minus 2xh minus h squared. This is going to be all over x, and then the expander form is x squared plus 2xh plus h squared, and then all of this is going to be over h, and let's not forget our limit because we haven't subbed the limit in just yet. Alright, and then now we're going to start canceling out the like terms, so these two are going to cancel, and that is going to leave us with limit as h approaches 0, negative 2xh times h squared over x, and we're going to expand the bottom part out too, so it's going to be x4 plus 2x cubed h plus x squared h, and then again all over h. Subbing out h from the top equation, we can cancel, subbing out h from the most top numerator, we can then cancel it with the denominator of the entire thing, which is going to be that h. So let's write that out. H times negative 2x minus h over x4 plus 2x cubed h plus x squared h all over h. And this is as h approaches 0. And then you can then cancel those out. And then you'll be left with the limit as h approaches 0. And 2x minus h over x4 plus 2x cubed h plus x squared h. Now, since it's no longer going to be indefinite, or yeah, indefinite, we can finally sub h in, so that's going to be negative 2x minus 0, and this is going to be 0 to the fourth plus 2, 0 to the cubed, plus this will stay as x, because it's x to the fourth, and this will also stay as x, but it's h, so that's 0, plus x squared times 0. Alright, so then you'll just be left with negative 2x over x to the fourth, and then one of the x cancels out, so it's going to be negative 2 over x to the x cubed, which is going to be your final answer. Alright, so for part B, we need to find the equation of the tangent line at x equals 1 for the function of f of x equals 1 over x squared, right? So the first thing we need is to find the equation, or to find the equation of the tangent line at x equals 1, we must first know the slope equation with the 2 points, right? So that's going to be y minus y1 equals x, or minus x, or x minus x1, right? But we have x1, we don't have y1, and we don't have the slope yet. To find slope, we need to find the derivative of this, and we got that already from the previous equation, so f prime of x is equal to negative 2 over x cubed, right? So now let's plug in 1 to see what our slope is. Our slope is just going to be 2. So this is the slope of the tangent line, right? And then to find the y value, you just plug it into the original equation. And that equals 1. So now we have everything. Let's plug it all in. Y minus y1, which is going to be 1, equals the slope, which is negative 2, times x, minus x1, which is also going to be 1. So let's expand the right side out. Negative 2x minus 2, y minus 1, and then we add 1 to both sides. Y equals negative 2x plus 3, and that is going to be the equation of the tangent line at x equals 1.